We will now go on to Team 2. Team Great Lakes, I want to do imaging research.
Hi, everyone. My name is Jen. I'm a second-year doctoral student from Johns Hopkins University, and we're going to talk about how to bridge the outcome research and EMR data with imaging data. So everyone here knows about DICOM, and so I'm not going to go deep on DICOM, but we're actually bringing the DICOM and EHR data using Odyssey platform, which has 450 health systems and 900 million unique patients contained in the consortium. So we're joining forces of these two wonderful open communities to make this happen. So who is Odyssey? What is Odyssey? It's an observational health data science and informatics community. And our really goal is to increase the value of healthcare data through large-scale analytics. And you may have not heard about this community, but you know all the NIC, all of us, and the N3C, FDI Cure ID, and all this great initiative behind that. We have the Odyssey community having that data standardized common data model. So our standardized data common data model is called OMAP, and it represents observation health data into a common format. So you could be in an institution A having a source 1, and in an institution B and having source 2, and that can be all transformed and formatted into common data model. And without sharing the data, so we protect patients' privacy and have the analytic method and results be able to share through GitHub, and everyone in open community can participate and support the initiatives. So current OMA format does not include medical imaging. And how sad is that for all of us? So we are creating two new tables, image occurrence table and image feature table in the red box, to include and leverage all the information that is already formatted in OMAP common data model. And this is a data science platform from the Odyssey community. And I'm going to show you how we are joining forces of DICOM and Odyssey. Okay. So this is a web browser, and currently it has synthetic data inside, and I'm going to pretend I'm an imaging researcher. I would like to see all the patients who has the CT chest scans. So I would go into procedure occurrence table and check. I want all students or patients have chest CT. And I can also, right now, this is the end of OMAP CDM. However, now we can add the slice thickness, which is an attribute we've harvested from the DICOM tag. Yep. Yes, and we're going to say we want slice thicknesses less than 5 millimeter. Then save the cohort. You can go to the generation and see how many patients we have. So we updated our OMAP data model to include patients from the SIIM database. So we have 2 patients that are SIIM, and we're going to talk about how we did that in the back end, and later show you in the Jupyter Notebook how you can pull that SIIM image on Jupyter Notebook.
Hi, I'm Delaney McElvain. I am a rising sophomore at Marquette University studying biomedical engineering and computer science. So here, this breakdown shows the translation of the DICOM standard into the OMAP common data standard. So for each element in the DICOM metadata, it requires 4 different features to translate it into OMAP. So the first feature on there is the concept. This is where the vocabulary goes within the common data model. The second one is the image occurrence, which provides the URI that allows the researcher to get the actual DICOM image.
Hi, my name is Nico Rios. I also go to Marquette University. I'm a junior studying biocomputing engineering and philosophy. So I'll sort of take over here for these last 2 tables. The image feature table can be arguably one of the more important tables here. And this serves as the actual bridge between feature and image. And it'll track which specific features belong to which specific images. And it's sort of the perfect bridge between DICOM and OMAP. And then the last table, which is the actual measurement table, which stores all the values for each of these measurements. This is sort of the process of how we actually did all these translations for these tables. You can see right there on the left, if we're going to focus on slice thickness, what's in that red rectangle, you can follow along with the other two red rectangles on the side, sort of how we took all of that information and sort of translated it into the OMOP model.
Hi, I'm Brianna. I'm a bioengineering student at the University of Pittsburgh. And so at this point, and we can show in our Jupyter notebook, the researcher has defined the cohort in Atlas and has also gotten IRB approval. So after that, IRB can grab those images and project them to the researcher using the Atlas Web API, which will subsequently call the SIIM API to get those imaging studies for those specific patient IDs that the researcher requested. And once the researcher has those images, she can easily run algorithms and conduct imaging research and pull those images directly into Jupyter Notebook, as we have shown here.
So we are on time, and we want to quickly shout out to all the team members who may not be here today, but help us achieve this goal. Thank you.
Great. Thank you, team 2. Any questions from the judges? Yes, Kevin.
Yep. Sorry, I'm sure about the volume here. What APIs did you use then to access I presume this was the data that was on the SIIM server. And so how did you get those details out? And then what, I presume there were Odyssey APIs used to feed things over.
Yeah, that's a great question. So Atlas is powered by the CDM database. So we updated the CDM database using SIIM images and patient information. So once you have the SIIM, once you extracted the acquisition parameters from one of the SIIM images and match the patient into a data CDM, you update the data CDM and it will power the Atlas. And then we use Atlas API to pull the patient from the original cohort discovery. And then we pull, using that ID from that patient, we pull from the SIIM API.
Okay, and so you're using Wado to get the...
Yes,
okay.
Wado URI, which is saved in the imaging occurrence table in the OMOP CDM.
Cool, thank you.
One more quick question.
Yeah, thank you. So I understand that there's work done to map OMOP to FHIR. And there's also work that has been done to try and align FHIR to DICOM. Did you consider, or can you speak to whether you tried to align that triangle of concepts?
Right. So in this hackathon present demo, we didn't do that part, but it is one of the work group in Odyssey is certainly doing that, and we'll be able to combine forces on that. Yeah. Thank you.
All right.
Yep. Thank you.
Thank you again, team 2.